Here's a new concept you want to note in your notebook. Highlight this like crazy because this is a very abstract idea. The definition says that a function f has a local maximum at x equals c if there's an open interval of x values from a to b which contain this c, such that for every x in that open interval from a to b, all of the y partners to that x, f of x, they're always going to be less than or equal to the y partners to that c. All right? Now, what we're saying here is that c in the neighborhood of x equals c in the neighborhood of x equal a to x equal b has the highest y partner. When we have that situation, when there's a local max located at x equals c, we call the local max value the y partner, f of c. The local max value is talking about the y partner. The function f has a local minimum at x equals c if there's an open interval of x values from x equal a to x equal b, which contains this x equals c, such that for every x on that open interval from a to b, their y partner will always be greater than or equal to the y partner of c. They'll always be taller than the y partner of c. So when that occurs, when you have a local minimum at x equals c, that means that the thing we call the local min value is the y partner to x equals c. It is f of c. So whenever they ask for a local min value or a local max value, they're asking for the y partner. Okay, given this graph of this function, it's got highs and it's got lows in it. They want us to find the local max and min values of f. Okay, they said the word values. So they're asking for the y partner, for the local maximum points and local minimum points. And find the values of x for which they occur. Okay, we're going to find the x partners too, but the values are actually the y partners. Let me just say to you, when I read that definition of the cloud, this is how I interpret it. If you can find a point around which you can form a neighborhood, and that neighborhood on both sides has no other point that is taller than your point in that little neighborhood, then your value, that y value that you have, the highest point, that is a local maximum. And on the other hand, if you find a point that's pretty low and you can draw a little neighborhood around that of x values on both sides, and that guy, that y value is the lowest y value for any other guy in that little neighborhood, that means you have a local min value for that y. Okay, so let's see how to answer this question. We're looking for local max, local min. So here I made a table. I'm going to list local max values. Those are the y values here. Then the x values where they occur, I'll write directly beside them. And then I'll have another column for the local min values. And I'll write their x values to the left of them. Okay, so first, here's a comment, which I just said. The values in the max val or minimum value are always the y coordinate. That's what goes under the word values, on the two columns that say max value and min value. The y coordinate, not the x coordinate. The x coordinates go in the middle on my table. Okay, so let's look at this graph. Let's look for a tall point on this graph. At x equals -2, we do have a tall point at y equals 3. Do you see that? At x equals -2, we have actually the tallest point on the graph at y equals 3. All right, so that means that you could draw a neighborhood around that point, -2, 3, and it would be the tallest point in that neighborhood. Similarly, at x equals 1, go up and look at the relatively tall point at y equal 2. In that situation, you could draw a neighborhood around that point at the ordered pair 1, 2, and that value 2 is the tallest value of all the points in that neighborhood. Now let's look at x equals -1. Now I'm writing the little neighborhoods around the -2 and the 3, and then the ordered pair 1, 2. I draw a little neighborhood. See, now it looks really clear. In that neighborhood that I drew around it, that corresponds to X value on the left and right. So in that neighborhood that I drew around it, those both are relatively big shots in their neighborhood. They're pretty tall, taller than everybody else in that neighborhood. That makes them local max values at 3 and at 2. And then the corresponding X values for those I listed as -2 corresponding to the local max value 3, +1 corresponding to the local max value 2. Now let's look for local mins. And I can see that it occurs in 2 locations. The first one happens at x equals -1. Look at x equals -1. There's a relatively low point there. What is its y partner? Its y partner is y equals 0. So we have, I'll draw the ordered pair, -1, 0, and draw a neighborhood. In that neighborhood, the lowest point, the lowest y value in that neighborhood is it's 0. 0 is the lowest y value. So that means that on the right side, I put a box around 0 because it's in the column for local min values. And there's one more local min value at x equals, 2. Look at the graph, x equals 2. It has a y partner of -1. And if you draw a neighborhood around that ordered pair 2, -1, you see that -1 is the lowest y value in that neighborhood. Now, there's no other local max or local min, because in order to be a local max or local min, you have to be exclusive in your neighborhood. I can't find any other point to put a neighborhood around and say, hey, you're the highest dude here or you're the lowest dude here. It doesn't happen anywhere else but those 4 neighborhoods that I drew. And 2 of them are local maxes and 2 are local mins.